Well, thanks for coming this evening. My name is Mike Milan. I'm the math department supervisor.
And I'm Lisa Mumal, principal at Centerville Middle School.
So we're going to talk a little bit about math tonight. There should be time at the end or any time during the session. If you have specific questions you'd like to ask, I'd be happy to try to answer them. So the title of the session is Why is math taught so differently? I don't know how many of you can identify with that sentiment. You feel like what you learned in school or the way you learn things in school seems really different than the way that they're teaching it now. And why is that? What are the things that it seems like the numbers haven't changed, so why have the teaching methods changed? And so that's what we're going to try and talk about here tonight, explain a little bit, show you a couple of examples of that, and then take your questions. So when I think about what is the goal, what are we trying to accomplish with math instruction, math education, we have a long-term perspective. We're not trying to accomplish all of the things that are up on the screen there, or they're the same things that are on your handout, trying to accomplish all of those things in any one lesson or one unit or even in one grade. But these are the kind of the broad goals. What is a educated math student, what do they get at the end of that? What skills do they have? And so these would represent some of the broad goals that we have, that students would be able to solve problems. They'd be able to work their way through unknowns. They'd be able to model things using equations and solve them. Just a lot of things there look for, and make use of structure so that when they see a problem, they would have the skills to work through it and the tools available to them. And so we need to take kind of a long view. How do you develop those skills? So if those are the skills we want them to have at the end, then how do you start building those skills in as early as possible? And what are the ways that we can, when we're doing math in 3rd or 4th or 7th grade, what are the ways that we can lead them toward the next math concept that they're going to see in the next course? So it's not just about getting answers, but we want students to really understand. I thought this was a little bit of a funny picture. I don't know if you can see it from where you are. What does it mean for a student to understand? How do we know whether they really understand or if they're just getting answers? So the instructions there are to write less than or greater than, but the student thought that they were just supposed to write or. So that's what they did. So I have something to give you to help kind of remember this analogy or example. But sometimes I think when we as a parent or are looking at math homework, and maybe the student's struggling with it, or you see the method or the example that's being explained or expected for the student to use, and it seems like they're taking a windy way to the destination. What is the reason for that? And so the first picture up there is to help to think, when you take a path, when you're going to take a walk in the woods or somewhere, the path that you choose from the beginning to the end is determined by what your goals are. Like sometimes you just want the fastest way from the beginning to the end. How do we get from the beginning to the end as fast as possible? And so you would pick one path to accomplish that. But sometimes you have a different goal. If your goal is to exercise, or your goal is to see a scenic view, or you have other goals other than just getting to the end as fast as possible, you might pick a different path to get there. And so I think sometimes that's what's happening in math classes, where we might have a goal to set a student up for success in a future concept, and so that might take them on a longer path to the answer because there's something that we're trying to get the student to understand. The second picture is just a different way of thinking about almost the same concept, but if you take this is a cylinder, just a wooden cylinder, and if you take a cylinder and you hold it this way, or shine a light on it this way, what shadow would it cast on the wall? And if you're holding it looking at the circle end, then it's the blue side of that picture. What you would see is a blue circle, right? And if you turn it sideways and you would shine a light on it sideways, what kind of shadow would you see on the wall? And you would see a rectangle. And that's what the orange part is supposed to demonstrate. And so I think sometimes there's just different ways of looking at the same thing, like it's the same cylinder, whether it has a blue shadow or an orange shadow. It's the same cylinder, but just a different perspective, a different way of looking at it, a different aspect of it that you might not be considering at one time. So I have a couple of examples. I'm going to work through a multiplication example, and then Lisa's going to do a fraction example. So on the board here is a 2-digit by 2-digit multiplication problem. And the first method we call the shortcut method, which is probably the method that you remember learning. And so with the shortcut method, there's some built-in shortcuts, some built-in sort of data management processes, ways to keep the numbers straight. So first we multiply the 3 and the 8, right? And that's 24. But we don't write 24. We write a 4 here and a 2 here. And there's a good reason for doing that. But I think usually if a student would ask, well, why do we write 24 like that? You know, probably the answer that you give is, well, don't worry about that. Just do it. It gets you the right answer. And from a math department supervisor, anytime that we're giving that kind of answer to a student, that like sort of raises a red flag for me. Like we shouldn't be telling students, just do it, don't worry about why. We want to infuse meaning in every part of the process and try to explain to them where the things are going and what they represent. So anyway, back to this problem. We got the 2 and the 4 in different spots. And then we do 4 times 3 is 12. So we multiply these two and then we add this one, right? And so if they say, well, how do you know which ones to multiply and which ones to add? Well, you multiply the big ones and you add the little one. Or you multiply the original numbers and you add the new one that's there. And why do you add anything in this multiplication problem? It's not super obvious in the process, but we just tell them to do it. And then we put a 0 here, and maybe we have a reason why, or maybe not. And then 2 times 8 is 16, so we do that separate number thing and maybe try and remember to not look at the 2, but now look at the new one. 4 times 2 is 8 plus the 1 is 9. And then we add all this together, right? So 1104. And it does get you the right answer. It's called the shortcut method because it has some tricks in it for managing the data to produce the right answer. So that's called the shortcut method. I think it's good for students to learn that method. I think it's a good method for them to use. But I'm not sure it's the best first method for them to use. And it might not even have been the first method that you learned. It's just the method you learned at the end, the one that you remember, and so that's the one you use eventually. So there's another way of doing this that's called partial products. And then we'll look at just a visual way of doing this for the visual learners. So with partial products, you set it up the same way, 48 times 23. But then this time, when you multiply the 3 times the 8, and that's 24, you just write 24. So already from my perspective, this is a little bit of an advantage, because if it is 24, then it seems like you should write 24, and it should look like a 24, and this does. And then when we multiply the 4 times the 3, what we would tell the students is this looks like a 4, but it's really a 40. We're going to infuse some meaning there and say it's in the tens place, so that's 40. What's 40 times 3? And that's 120. So we're not just saying like write a 0 on the side or something like that. There's a reason there's a 0 there, because it's 40 times 3. And then we do the same thing when we go this way. This is really a 20. 20 times 8 is 160. So we're not just writing a 0, but we're telling them why there's a 0 there, because we're multiplying 2 tens times 8, or 20 times 8. And then finally, we do the 40 times the 20, and 40 and 20 is 800. Now, it's no surprise that you get the same answer both ways. Like, you better get the same answer both ways. That's the way math works. So we're going to add these things up. And so we get 1104 both ways. And you might say, well, why do we have to write all of these steps? And I would say, well, you know, they're not getting paid by the hour. If they have to write a few extra steps, but it can infuse some meaning in the process, then that's what we really want to go for. And so that's just a quick example of 2 different ways of looking at it. And then if we're setting students up for the future, we might want them to think about this with something like an area model, because this can set them up for how do you multiply binomials in algebra. And it's just a different way of thinking about the exact same thing, but break the numbers apart, 40 plus 8, 20 plus 3, and that what you really get here is 4 rectangles. And you get the same numbers here that we got before. So we get the 800 would be this one, 20 times 40. And we get the 160 here, the 120 here, and the 24 right there. And then you would add those things up and you get the 1104 that way. But it's just another way of managing the data, organizing the data so that they can understand where the pieces go. And one of the big things when we get to high school in Algebra 1 is when we multiply things that look like this, except it's got an x plus 2 and an x plus 3 or something like that, that you really do get the 4 terms. You get 4 things when you do this and not just 2 things. So this can build in them even in, this is a problem they could probably do in 4th grade or somewhere around there. It can set them up. You wouldn't do the algebra in the 4th grade, but set them up for understanding that when you multiply a 2-digit times a 2-digit number, there's really 4 things that you're multiplying and then adding those 4 things together in the end. So that's a quick example of why we would take something that maybe we did in the past as just a process that we just said, well, don't worry about it, just do it, and try to expand it, try to find a way that communicates more the meaning behind it and helps them to see it. And now Lisa's going to show you an example with fractions.
So the whole idea, our whole point here is in math classes we're trying to make meaning behind the numbers. There's patterns to numbers. What I like in his example is you can see 124 and the 120 make up the 144. And that this 160 and the 800 add up to the 960. And we would hope that students see the connection between the partial products to the traditional way of multiplying. Another example of making meaning behind the math. Do you mind that I erase it?
I don't mind. I just remembered that I have the microphone, so I have to stand closer. Whoever watches the video will only get video, no audio.
And I figured my voice was loud enough that it would be picked up. But I'm going to talk about this word problem here. Many of us, when we were in school, saw word problems like this. Bill and Ted worked together to mow a lawn. Each is responsible to mow half of the lawn. Bill only mowed 2/3 of his half. How much of the total lawn did Bill mow? So back in the day when I went to school, I was taught that if I saw the word of means multiply. So I would have, looking at the second, or actually the third sentence, Bill only mowed 2/3. I write 2/3. I see the word of. I would know that's multiply. His half. I would multiply by a half. I memorize it to multiply. I would multiply the numerators and multiply the denominators. Right? And then I was taught to reduce a fraction. I would divide the numerator and the denominator both by the same number. That would be 2, the common factor or that they have, and I would get the answer 1/3. Right? Trying to build meaning behind the math. Now what we're doing with students is we're starting with a picture, a concrete model of the math to make meaning. So my model, I'm going to use a bar model, it's called. So I'm going to draw a rectangle, and this rectangle represents the lawn. Okay? What I know is that Bill and Ted work together to mow a lawn, and each is responsible to mow half. So I'm going to split that rectangle in half. I'm going to remind myself maybe Bill needs to mow one half, Ted the other. Reading further down the word problem, Bill only mowed 2/3 of his half. So what I'm going to do is take his half here, and I'm going to break it up into thirds. Okay, 1, 2, 3. And I'm going to shade in 2/3 of his half of the lawn. right? Now what I can see in this model, without multiplying, without remembering to multiply the numerators and the denominators, looking at this, I can see that 2 of the 6 equal parts is how much Bill moved, right? By looking at this, it meaning that a fraction of a fraction, you get a smaller piece, right? A smaller fraction. This makes meaning of what does multiplying fractions mean in a word problem. After doing many word problems like this, by drawing a picture, what we would hope is that students say, oh, I know a shortcut. Why don't we just multiply the fractions? We always get the same answer. And you go, yes. And they came up with the pattern. They came up with the rule. They made the connection after understanding what multiplying fractions means.
And I think every time, I mean, there's research, there's people that spend their days and years trying to find new ways of communicating this math to students. How do we help students to understand this in a more in-depth way? And I heard somebody explain it that like some of the math education in the past was to turn kids into students that could calculate or compute, that they would just be able to take the numbers, put them together, and get answers. And if that's the goal, then some of those shortcut methods are okay, but I think we have different goals for the students. We really want them, I mean, if the thing that they need to do is to calculate and to compute, we have calculators and computers for that. And so at some point, they're going to lean on those. I mean, most adults don't multiply big numbers and decimal numbers and do those kind of calculations without a calculator. At some point, we lean on technology for that. But what we really need is to understand those patterns and the connections and how does the information fit together and how do you pull it apart and not lose anything? How do you model it with an equation and how do you use that equation to get new answers and new solutions?
Mr. Brown, can I go one more step?
Absolutely.
I never made the connection to reducing 2 6 and how you get 1/3. What I would show students is this rectangle is made up of 3 equal parts. There's 2 mini rectangles there, 2 mini rectangles here, and 2 mini rectangles here. Now I have 1 shaded part out of 3. That's how I would show that. I would show students that 2 6 is equal to 1/3. Instead of saying, oh, divide the numerator and denominator by 2, and that's how you get 1/3. I make that connection. I'm sorry.
Good. Any questions connected to those ideas before we move into the next part of the session? Yeah.
Sometimes my daughter will say, well, can't I just do it the shorter method because she might understand both methods. So as a parent, should we encourage that or not?
Yeah. If I go back to those last two, it says, look for and make use of structure and look for and express regularity and repeated reasoning. When you have a student that sees those kind of shortcuts, like we want to celebrate that they're seeing the connections and seeing those kind of things, and we want to build that in students. So everybody's going to have those awakenings at different moments. So, you know, it's a little bit hard to say with each specific instance, like how's the teacher going to react when they see those kind of things on the paper. But I think certainly that's what we want students to get to see, that, oh, when I do it this long way, here's the patterns that I see, and I see that there would be a shorter or a different way to get to this answer. Yeah?
Question I have is, all of this is great. When is it developmentally? Like you said, there's a lot here for a single kid.
Yeah.
So when is it age appropriate that their brains have actually formed enough to create these patterns, to understand them?
Yeah.
Because the dichotomy of it all is we have Common Core and we have a federal mandate that says they need to do this, which forces you guys to teach to the test.
Yeah.
So in essence, you're telling them, we want you to take the long way, but now by God, you have the time test and you better get this done.
Yeah.
Because if you don't, then your teacher's going to get punished.
Yeah.
And your teacher's going to have to go to classes to remediate, and the school gets punished. How does this all connect?
Yeah. I mean, probably what you're describing there, I'd say, is a little bit stronger than the reality of it that we're experiencing. I mean, there are certainly standards to hit each grade level, but there's an understanding that, you know, in fourth grade, that doesn't mean every kid is going to hit those standards. Some kids are ready to do the fourth grade standards and the fifth grade standards. Some kids are still working on those third grade standards, and we're trying to get them up to the fourth grade standards. And so, you know, there's a lot of language like no child left behind and all of those things. I mean, these are goals and these are aspirations, but there's all of that in the context of an understanding that kids are different and we're going to help them reach those at those different paces. But at what age are we hoping that kids will be able to multiply big numbers together? Like there's a specific grade where that's our target. And if students aren't hitting that target, then we're going to pay attention to it. And we're going to say, well, what are the different ways that we can help this kid to learn those things? So there's a lot of strategies that may look different from kid to kid. And we're not going to take them on the long path just because. I mean, if there's a purpose and a meaning to it, then let's try to get them to understand it as much as possible. But all of those sections on multiplication end with the shortcut method. And so, you know, we do expect the kids to understand the shortcut method. And so it's not that we don't ever show them these shortcut methods, but that we try to build that meaning in as much as they're able to handle. And then we move on. So.
What happens if they're not ready to move on and they can't handle it? And then they aren't approaching, when the assessments come out to the homes of all these parents, and they're saying your child is not grade level appropriate yet, or things like that. What happens then?
Yeah.
Because the only reason I'm asking is,
Sure.
I was in education for 15 years. I've seen this stuff come and go.
Mm-hmm.
And when you have an administration stand up there and say, this is No Child Left Behind, and by 2014, all children will be proficient in reading and math. Well, here we are now, 2016. It didn't happen.
Sure.
And that went away.
Yeah.
Now something else is here, which drives them, and then parents get worked up. Everybody gets worked up. We're not meeting our goals.
Yeah.
Teachers have to go to remediate. Then PSSA turns to Keystone.
Yeah.
And that's, now we got to teach the curriculum of Common Core to the PSSA test, and yet at the same time we want you to extrapolate, we want you to build, and yet you're under the gun.
Sure.
This is what I'm asking.
Yeah. Go ahead.
Well, two things. You've asked two questions. My answer to your first question was, it's not till a kid understands the math, do they master it and can do it efficiently, okay? So a kid could sit there and be like, oh my goodness, I can't remember the next step or what to do. Or a kid could sit there like, I know why, and crank out the problem. You know, I always say there's an art and science to teaching. There's a balance to pushing kids, and then also the art of motivating them, the art of making them understand why. And teachers are constantly trying to balance that. I also think that your second question with what happens if they don't understand. Well, one, you said administrators are always saying, you know, they need to know these ways. In all of my education, I have never, ever heard anyone say that a kid should not understand why about math. I haven't heard that at all.
Right.
And so our whole point here tonight is we need kids to understand the why of mathematics. And it's through understanding math that they will become efficient. I'm a math person because I cannot memorize, but I understood it. And that's why I still, at age 29, I still remember why, you know. But then also what happens to that kid that doesn't get it? All of our elementary schools have instructional support teams where if that time in class with their teacher is not enough, there's additional time with a specialist that they get with targeted instruction to help them understand. At the middle level, we're working to get there to provide this second layer of help for kids, that class time isn't enough. Because we all know not everybody learns at the same rate.
And I try whenever I get a chance to sort of lower that anxiety and pressure that we want to see every student grow by at least a year every year. I mean, that's really our goal. So if a student's a grade level behind, we want to get them to grow a full year and make up some of that gap. I mean, that's our goal. And so we'll throw whatever resources we have and strategies and techniques. How do we help a kid that's a grade level behind to close that gap as much as they're able to in that year? And so, I mean, that, you were familiar with the goal that all kids would be proficient. I mean, I've been around long enough that nobody believed that, right? We all knew.
Right.
I mean, if
administration said this is here,
yeah,
this is going to stay, it's not going away, you're going to do it.
And it was the goal, and like we worked to build things and do our best and try to move forward. And then when, at the point where it became unreachable, then you're right. They rewrite it and they say, like, now we're going to adjust the goals.
Well,
but we always,
I mean,
we always want to be moving forward and paying attention to, if there's a better way to teach this, then let's use that better way. And if there's something that we see that's confusing kids in algebra, then let's look back and say, where did we first introduce that concept? And was there a way that we introduced it that built in that confusion even years later? And is there a better way that we can address that? And so I think that's going to be a process that's always moving forward. We're always going to be finding things like that and fine-tuning things. And I think it's a process because when you make those changes, the teachers that are teaching at that lower level, that's new for them too. And so they may not have the background to see all the interconnectedness. And so it is a fairly complicated and involved process that's going to take some time to get it right.
The last thing I'll say is about, especially math, I taught history on the high school level.
Yeah.
And one of the things in a faculty meeting when they introduced state standards, remember that 1.1, make sure up on your board you have 1.1, 2.4.
Right.
Great, what does all that mean?
Right.
And when I said about math, what is one of the things NASA did? To communicate with anything out there, they put everything on a gold disc and it was all mathematical language. So it's a language, and I said, why aren't we teaching this on an elementary level that math is not just a subject matter, but it is a language? And they all looked at me like I had 3 heads.
Right.
But it really is a language.
Sure.
And that's what you're basically saying here. This isn't just adding up numbers and finding a shortcut. You're saying this needs to translate into your brain as some type of communication to form not just patterns, but comprehension, is what you're saying. So I was just wondering how this district will manage that, which I think is a lofty and great expectation and really how it should be done, versus get it done, time test, and your kid isn't performing to grade level standards, and now they're not going to do this, we're going to yank them out of class, we're going to get them supplemental education here, and they're going to be stigmatized from that, going, oh my God, I suck, you know, I'm not being able to do this, and then boom.
Yeah, I mean, some of that I guess I would think of as like a different way of looking at it, like maybe looking at it this way, and maybe it's the same thing, but can we put a different spin on it and say, hey, if we see that there's a better way that we can come around you and support you and help you to understand this thing that you're confused with, like I don't know that has to be a stigma thing that's a terrible experience.
But I'm saying
and
as a kid, a lot of kids process
sure,
things that way.
yeah,
They see it as stigmatized, and we're in this culture of these, you know, feeling offended or whatever.
Yeah.
You know, now my child feels stigmatized.
Right. Yeah.
Well, you know, you get it. You know?
Right. Yeah. So, I mean, I guess I would just say we want to partner with parents in that process to help frame it for a kid that says, hey, this is a place where we care about you, we want you to do well, we're going to support you in your learning and moving forward. So, I don't know that will be successful with everyone, but that would be the goal.
So you're referencing the support systems for students. Are there a list of like early interventions that are used for students? My son's in first grade.
Yeah.
You know, things aren't, I'm not saying my son has issues with it.
Sure.
I'm saying, what would those, is there a list made available to parents? Is there something that
Well,
we
maybe
have?
even the second part of
Right.
We
Let
have
me.
2 minutes left of this session, and you're going to show parents if their kid needs
Yeah.
help, what they
So,
can do.
so this isn't the only support that's available, but I just wanted to show one while you're here, just to see. And there's other supports that are available. Communicate with the teacher, with the principal, find out what's available. But this is one that's posted online. This is available for all parents. I call them parent pages. On your handout, there's a tiny URL that you can type in to get to a page or a web page that would have a list of folders that you could open. So whatever unit the kid's in from kindergarten through 6th grade, there's a folder for each unit. So you pick their grade, pick the unit that they're in, and there's a page that looks like this. And so what these are, any page, any concept that a child is stuck on, you need to know what lesson they're in. So if they're in, this one's a 2nd grade unit 5 page. So if they're doing hours AM and PM, that's lesson 1 in that unit. And if they're stuck on that, then there's 2 pages available for you, L81 and L84. That's on the same web page. You can get those 2 pages. And the reason I picked those to list there is because when you open those pages up, what you'll see there is an example that's worked out. Not just a blank example, but one that's worked out. And then a couple practice problems. So for every lesson that we do, kindergarten through 6th grade, there is at least 1 and often 2 pages like this that get at a basic skill that's involved in that lesson. So if they're stuck, this would be my recommendation for the first place to go to see if they've got those basic skills and are able to apply them in the lesson that they're in. There are also answer keys posted there. It says parent answer keys right on the page. So if you're not, probably many of them you would be able to get the answer to, but if you're stuck or want to just check, there are answer keys posted as well. The other thing, I think it has video links there, and if you have questions like, this doesn't have all of the examples and like we did up here, but if you want to know why we teach things the way that we do, there's videos that kind of explain a little bit of the thinking behind those kind of teaching strategies. If you want more help than that, we do have instructional support teachers, we have learning support teachers, we have a lot of ways that students get help in math and other subject areas. Yeah, and usually their student workbook would say what lesson they're on. Yep. Yeah.
There seems to be so much, I have 3 children in elementary school.
Yeah.
And there seems to be so much focus on the reading and reading specialists and 3 different assessments in reading and data of where they are. Is that also the intent of direction that math is going to go? I kind of feel like reading is way up here and math is still way down here.
Yeah.
I feel there should be more emphasis on the math.
There's a couple different, every unit has an assessment, and there's a couple different times when we do some extra testing, specifically in 5th grade, when we're trying to figure out which kids are ready to start pre-algebra. There's a pretty big process there with some testing. There's not, at this point, there's not that benchmark testing throughout the year. The PSSA at the end of the year gives us a lot of data about where the students are on grade level or wherever they are.
But even when I look at my child's homework, reading is every single day, 15 minutes.
Yeah.
Maybe once, twice a week. It's not like a balance.
Yeah.
Between the 2 subject areas, and I feel there's so much data that shows we're behind in math. Our scores later on in middle school seem to drop in high school.
Yeah.
But why it's not beefed up more in the beginning.
Yeah, that's something that I'll have to dialogue either more with you, get back to you about it, and find out kind of the specifics there. But I don't think I have a good answer to that at this point.
To strengthen the math, or is it still trying to fuddle through the?
Well, the quick answer to that is yes. We are working on the math to beef that up. I'm the math department supervisor, so that's like my whole world to say, what does the data show? How can we, leverage the resources that we have to build that? As far as the specific expectations in whatever classroom your kids are experiencing, I don't know that I would have the details there to dig into that right now. Did you want to add anything to that?
I think for years reading has always had more resources. If a kid can't read, they're not going to read the word problem I went over. I do believe that as a district that there will be benchmarks both in reading and math. It is Dr. Adams' goal to have benchmarks grade 3, 6, 9 to try to give us a better feel in both English and language arts and also math. But unfortunately, there are many resources that you can purchase that are research-based for reading, more so than is available for math.
We are a little bit over time. I know there's one more session. If you have further questions, you're welcome to stay and ask, but we're going to close the session at this point. I did bring extra ones of these. If anybody wants one as a memento of this wonderful time that we've had together, you're certainly welcome to have one. So, thanks for coming.